Hey everyone, and welcome to the Explainer. Today, we're going to do something a little different. We're going to put on our detective hats and dive into the secret world of numbers. We're about to crack a code that's at the very heart of mathematics, revealing this hidden division that sorts almost every number into one of two teams.
So let me just throw this question at you. Are all numbers created equal? I mean, it might seem that way, but the answer is not even close. You see, some numbers are these fundamental, indestructible building blocks, while others, well, they're built from something else entirely.
So here's our roadmap for this investigation. We'll start by seeing how the number world is divided. Then we'll get to know the two main players, primes and composites. We'll solve the little mystery of the number one, and then, and this is the best part, I'm going to give you your very own prime testing toolkit.
All right, first up, a world divided. Let's get right into this fundamental split at the heart of, well, all of number theory.
And here it is. This is the big idea for today. Every single whole number, once you get past 1, has to be in one of two clubs. It's either prime or it's composite. There's no middle ground, no gray area, that's it.
Okay, so let's start our investigation with that first group, the primes. These are the fundamental building blocks of math.
So here's the official definition. A prime number has exactly two factors, and a factor is just a whole number you can multiply to get that number. For primes, those two factors are always just 1 and the number itself. Think of it like a super exclusive club with a very strict two-member-only rule.
You know, a really great way to think about this is that primes are the atoms of the number world. You just can't break them down into smaller whole number pieces by multiplying. They're the purest elements we have. And hey, this isn't just a math curiosity. The fact that huge prime numbers are so hard to break down is literally the secret behind all the encryption that protects everything from your credit card numbers online to government secrets.
So here are some of the usual suspects. 2, 3, 5, 7, 11, and the list just goes on forever. But look closely at that note, because this is a great piece of trivia. The number 2 is totally unique. It's the only even prime number in existence. Why? Well, think about it. Every other even number is, by definition, divisible by 2, which means it automatically has more than two factors.
Okay, next up is our second group, the composite numbers. So if primes are the atoms, you can think of composites as the molecules they come together to form. And the definition for a composite number is basically the exact opposite of a prime. It's any number greater than 1 that has more than two factors. These are the numbers that you can break down into smaller pieces.
Let's look at the evidence here. Take the number 4. It has three factors, 1, 2, and 4. The number 6 has four factors, 1, 2, 3, and 6. And you can see with 9 and 15, they're all built from smaller parts. They all have more than just two factors.
So let's put them side by side just to make it crystal clear. Prime, exactly two factors. Composite, more than two factors. That's it. That is the fundamental difference that splits the entire world of numbers.
All right, time to solve our big mystery, the case of number 1. It's the one number we've been ignoring so far, and for good reason. It's a real outlier, and it doesn't seem to fit anywhere.
So what do you think? This is a classic trick question in math class. Does the number 1 belong to Team Prime or Team Composite?
And the answer is neither. The number 1 is in a category all by itself. Just remember the rules we talked about. Prime means exactly two factors. Composite means more than two factors. Well, 1 only has a single factor, itself, so it doesn't meet the entry requirements for either club. Case closed.
Okay, now for the really fun part. It's time to equip you to become a number detective. Let's open up the Prime Testing Toolkit.
These are your first-line investigation tools. They're the quick checks to see if a number is obviously composite. If a number ends in an even digit, you know it's divisible by 2. If its digits add up to a multiple of 3, it's divisible by 3. And of course, if it ends in a 0 or 5, it's divisible by 5. These are your easy wins.
But what about the really tough cases? For those, we have this brilliant short count, the square root rule. Instead of testing every single number under the sun, you only need to test for divisibility by the prime numbers up to the square root of your target number. It saves a ton of work.
Let's solve a case together. Is 149 prime? Well, first, the square root of 149 is about 12.2, so we only need to test the primes that are less than 12. That's a short list, 2, 3, 5, 7, and 11. So we run the tests, it's not even, the digits don't add up to a multiple of 3, doesn't end in 5, and a quick check shows it's not divisible by 7 or 11 either. It survived. so we can confidently declare 149 is prime.
Let's try another one that often tricks people, 91. It passes the 2, 3, and 5 tests, so it really looks like it might be prime. But what's the next prime on our list? It's 7. Let's check. And bingo. 91 divided by 7 is exactly 13. We found a match. So the final verdict is that 91 is a composite number in disguise. And there you have it. From those simple divisibility rules to the really powerful square root method, you now have the toolkit to investigate any number, figure out its true identity, and crack its code. And now I'm leaving you with one final case file. Twin primes are pairs of prime numbers that are separated by just one other number, like 11 and 13. So your mission, should you choose to accept it, is to use your new toolkit to find the pair of twin primes hiding somewhere between 50 and 80. Good luck, detectives!